So I've added the labels here already that are in part 2, descriptive statistics, the mean of the averages, the standard error of the mean, sample size, 2.6 divided by the square root of 5. So these are labels. And then I just need to add those items in. So we need the average, so equals average, average of, and again I need B2 through B1001, and so I'm going to go down here to row 10 and then add a 0 and a 1, and so you see I have that average for that, and I hit enter and it's around 5, and then equals, and I'll do the standard deviation, same thing, again, you know, and I could just type this in, but for me I kind of like doing that combination of clicking on the stuff and finishing out if it's really long rows or long columns, that is. And so there's a standard deviation, and sample size I'll just enter a 5, and then here I'm just going to enter what I have right there, except beginning with an equal sign. So one thing I guess I could do is I could go there and I could highlight all that and do a copy. It won't let me do it with the mouse up here, but I can do a Control C. So now if I go in here and I say equals, and then I do a Control V, you know, there's my formula that I wanted. Now I don't want the square root of 5, just because if I update the 5, I'd like to have a formula. So I'm going to change, instead of 5, I'm going to click here on cell K4, and it says K4, and I think the spacing's okay. You know, I've got 2.6 space slash. I think that'll be okay. If not, it'll give me an error. Yeah, it was fine. And the thing we're looking at here is the fact that that number and that number are really, really close. Now, this number is from random sampling and so forth, so I don't expect it to be exact. But this number is, well, more exact. I say more exact because I don't know if 2.6 is truly the standard deviation of, for instance, you know, all of these are our population of 1s through 9. But you know, notice here that as you look at the standard deviations, if I were to tell you that the theoretical standard deviation is 2.6 for the whole population, then getting these in here, that looks reasonable. And you know, if we go to 45, I got to come over here and go way down to the bottom. But notice 2.6, 2.6, 2.76, 2.6, 2.74, and by the time you get down to 450, when you look at those, they're way at the bottom, but again, 2.5, 2.6, 2.55, 2.64, 2.59, you know, it's looking like they're around 2.6. So all of these standard deviations, no matter how big my sample size, tended to hover around, and I'll call it hover, or you know, they were centrally located around the number 2.6. Whereas definitely when I go here, that ain't no stinking 2.6. I mean, that is 1.6, but here we're giving you a hint as to where or what's happening. You know, to say where that number comes from, well, it sounds like because we give you this formula, then this number up here had to be true. Well, no, it's the opposite of that. because we see that pattern in this number up here, then we realize that, this is what's going on, and theoretically one can show that. Okay, and we'll see that more when we increase the number of observations per trial. Okay, but that's adding those descriptive statistics and calculations, and so we'll call that good.